All right, good afternoon, everybody. Today we're going to talk about one of the most important foundational systems in modern game development, and that is blueprints in Unreal. More specifically, I want to discuss three things. First, what blueprints actually are. Second, why I strongly recommend students learn blueprints before diving deeply into C++. And third, how blueprints relate to many other node-based systems used throughout the game industry, including materials, shaders, visual effects, animation systems, and AI tools. What is interesting is that once you understand blueprints, you begin to realize that you're simply not learning one tool, you're learning a way of thinking that appears throughout modern game development pipelines. So let us begin with the basics. Blueprints are Unreal Engine's visual scripting system. So instead of writing traditional code line by line in text, developers create logic, visually used nodes connected together with wires. Each node performs some kind of operation. Some nodes store information, some nodes make decisions, and some nodes trigger events. Others communicate with different systems inside the game. At first glance, students sometimes assume that blueprints are somehow less serious than programming in C++, but that is actually a misunderstanding of how modern development works. Let's briefly take a look at an interview with Tom Gierman, co-founder of Sandfall Interactive, on how they use blueprints in Clair Obscur Expedition 33, their hit-selling game.
Make things worse for everyone.
I am Tom Gamin, one of the co-founders of Central Interactive, and we recently released Clair Obscur Expedition 33 on PC, PS5, and Xbox. Everything started as a passion project from my friend Guillaume. There was already a love for writing on his side and content creation, and me on the technical side when I started to helping, from time to time, just on some small gameplay features here and there. I think the main way the structure of the engine helped us grow and deliver this project in the end. It started really early when it was only Guillaume and myself, because Guillaume is not a programmer. It was important to not prevent him from, working on the project. If I were to do a feature, it had to be done in blueprints, because I couldn't humanly, do everything on my own on the gameplay side. Guillaume was always like a big contributor. We have a ton of blueprints, and all the core logic of the game actually ended up being blueprints, even features entirely made by programmers. It was a faster way for us to try to innovate on the gameplay instead of trying to innovate, on some heavy technical stuff that we just didn't have the manpower. And as we moved forward and the team grew, everybody was blueprint fluent, so to speak, and they would contribute directly in the core logic. Everybody had a lot of freedom to do their job thanks to that particular tool.
Blueprints are used in both AAA development and, as you saw in the video, indie development. Blueprints are not just useful because they help students learn programming logic. They're useful because modern game development as a whole is increasingly node-based. So what students learn in blueprints transfers into many other professional tools. For example, let's look at materials. In Unreal Engine, the material editor is also node-based. Instead of building gameplay logic, you're building visual surface behavior. You're controlling things like color, roughness, metallic, and so on. But the underlying structure is remarkably similar to blueprints. You still have nodes, you still have inputs and outputs, and you still have data flow through a graph. You still have reusable functions. So students who understand blueprints often adapt to material systems much faster, and they already understand the visual language of node networks. And the same thing happens with visual effects systems. Modern VFX pipelines frequently rely on node-based workflows. For example, in Unreal Engine, the Niagara system is heavily node-based. Artists visually construct particle behaviors. They define velocity, spawn rates, color over time, and so on. So to conclude today's lecture, I want you to think about blueprints not as a shortcut around programming, but as an introduction to systems thinking. They help students understand logic, events, communication, flow, interactivity, and modular design. And more importantly, they'll introduce students to the visual language used across modern game development tools. And once you become comfortable with that way of thinking, transitioning into more advanced programming becomes much more manageable. Next class, we'll begin looking at actual blueprint structures inside of Unreal Engine, and discuss how events, execution flow, variables, and object communication work inside a real project environment.